Okay, so just quickly, a little bit, starting with an overview and diving down into some more details. As most of you no doubt know, NCHS is developing and deploying a new National Vital Statistics System application programming interface for data exchange. An API is really simply a set of rules that describe how two systems can communicate with each other. And we'll get into some details on how that's expected to work for this particular API. And this API that we're talking about today, the NVSS API, can be accessed by jurisdictions to submit mortality data to NCHS and also to receive acknowledgements, errors, and coded data in response. So there's two-way communication going on here. There's data flowing to NCHS and also back to jurisdictions. An API like this, one of the reasons to focus on modernization efforts like development of APIs is because they allow automation of communications in a robust way that allows for sort of repeatable processes, right? The ability to submit in a regular way and get responses in a regular way. This automation will hopefully improve timeliness as records are essentially submitted as soon as they are considered complete enough to submit by the jurisdiction. And also the intent is to reduce burden on vital record stakeholders. Automation essentially means that systems are taking care of shuffling data around, and people can spend more time focusing on the actual data itself, and the value that the data provides. This API implementation that we're talking about implements the NCHS messaging infrastructure section of the FHIR messaging for NVSS documentation. And I am going to paste a link into the chat where you can find that. You should see that in the chat now. So, basically that's just a description of what the API does and how it works, right? What its processing steps are. And this API is eventually going to be hosted as part of the Steve2 system. Our colleagues from NAFSIS will be talking about that more later today and in the future as well. And that's expected to be the main submission path. And the API will also be hosted at NCHS. This is intended as a backup submission path. And just to take a look at what this looks like. So this is a very high level view of the expected flow of mortality data. We have funeral directors, coroners, medical examiners, physician certifiers, all providing information to the jurisdiction, perhaps through various systems that they themselves use. And then the intent is to share that information from the jurisdiction to Steve. And of course, information will be returned from Steve back to the jurisdiction. And you can see that in this diagram, Steve then further communicates that information with NCHS. So that's that expected primary flow of mortality data using the Steve system. And the benefits here, of course, are that Steve is not just used for exchange of information with NCHS, it's also used for trading information with other trading partners, other data partners. Continuing that role of Steve is a key part of this modernization effort. The backup flow of data is just a simpler version of the same diagram in that data is still flowing to the jurisdiction electronic death registration system, but then could be submitted directly to NCHS if that was for any reason necessary. I'll also note that that FHIR interface is also the expected interface by which Steve itself will communicate information to NCHS. So, we've talked about an API and how it's essentially a system to define how two systems communicate with each other. This particular API uses what's called a RESTful approach. REST stands for Representational State Transfer. It's not particularly important to understand the details of REST. There's a nice long dissertation on REST itself, describing the architectural style itself. But the key thing to take away today is that REST is based on some of the foundational technologies that make the internet possible, such as the Hypertext Transfer Protocol, or HTTP, and JavaScript Object Notation, or JSON. The key part of REST is that it uses technologies that a lot of developers are familiar with. There's a lot of tooling for, there's a lot of support for, and that makes implementation easier. And REST offers a stateless request response pattern that makes building applications straightforward. Basically each individual request stands alone, and REST implements some verbs, basically some actions like get and post, which is getting information from a server or putting information to a server. And we'll see how those come into play a little bit later on. So we've talked a lot about FHIR throughout the last months and years. The API is built using FHIR. FHIR is itself a RESTful standard. It's intended for the electronic exchange of health information. And the focus on health data and the basis on internet standards make it a really good fit for exchanging mortality data, because mortality data contains a lot of health data and demographic data, which FHIR does a very good job with. And its use of those internet standards, that RESTful approach, offer some benefits on the implementation side. The fundamental building block in FHIR is what's called a resource. And all that is a well-specified way to represent one concept, like a patient or a condition, right? And if you think about a death record, it's really just a collection of information. Some of it is information about the decedent, which can be represented using the patient resource. Some of it might be conditions, such as for cause of death. Some of it might be observations, like did the decedent have prior military service, right? So those resources are all put together to create a FHIR death record. When it comes to the API, it's actually even simpler than that. The API uses something called the bundle resource to represent and share information about mortality data in the form of FHIR messages. If you've heard of talk about FHIR messages in the past, the FHIR record is essentially a mortality record, information on one decedent. A FHIR message is essentially the envelope that record is wrapped in when being sent, and the FHIR resource for that envelope happens to be called a bundle. And the API uses FHIR messaging. It's a standard part of the FHIR specification, and the reason for using something like FHIR messaging is to support reliable delivery, right? The FHIR messaging makes use of things like acknowledgements, resend if there's a timeout, and so forth. And that means that we can be more confident that our records are being sent as expected, have been received and processed correctly. And I can go ahead and paste another link into the chat. This is just a link to the HL7 FHIR specification, the messaging portion of it. It's not critical to understand that, but if you have any questions just about FHIR and FHIR messaging, that's a good resource for an introduction to the topic. So the API supports a number of standard interactions. A number of them are what would be considered post interactions. That's essentially a jurisdiction pushing information to NCHS. So there's a couple of different types of messages that can be posted. One is a submission message that basically says this is a new death record. It represents information on one particular decedent. That record can be updated. Say there's an amendment to the record or if more information has been collected. So an updated record can be posted to the API. If a record needs to be voided, a void message basically voids one or more existing death records. And that's just used to indicate that a previously submitted record is no longer a valid record. Posting would also be used for alias messages. If a decedent has alias information, which is used primarily for the NDI, any additional identifying information can be provided using an alias message. That's very similar to today, how in IJE, a separate record is used to provide alias information on a decedent, a separate line in the IJE file, which is essentially a separate record. And then finally, the API supports posting of acknowledgement messages. When NCHS sends a coding response message back to a jurisdiction, the expectation is that the jurisdiction will acknowledge the receipt of the coding response message, and that can be posted to the API. So this is all talking about information flowing from the jurisdiction to NCHS, but of course this is a bidirectional API and that information flows in both directions. So the API supports GET interactions as well. A GET will retrieve at this time 3 different types of messages. One is an acknowledgement message. That's basically saying that NCHS has received a jurisdiction submitted record, like a submission or an update or a void. There's also error messages. If a jurisdiction submitted message has some type of problem being processed, an error message can be returned. And then finally, coding response messages. Cause of death information, race information, ethnicity information are all coded by NCHS, and that coding information is returned to the jurisdiction. Message flow from NCHS to jurisdictions is accomplished by a jurisdiction system polling the API and looking for new responses. We made that design decision so that jurisdictions will not be required to set up a listening endpoint. We've certainly heard from some jurisdictions that there are governance or IT challenges in setting up a listening endpoint for an API. This approach allows a jurisdiction system to essentially pull the responses from NCHS rather than having them be pushed to the jurisdiction from NCHS. It's the same flow of information. The only thing that's different is who's initiating the connection. This diagram basically, at a very high level, captures that flow. So you can see on the left-hand side, there's a diagram that basically has sort of 2 sides, the vital records jurisdiction and the National Vital Statistics System. A death record submission, which is a post, makes use of the FHIR messaging implementation guide to provide essentially the envelope. And then the content of that envelope is the death record itself, which is defined by the VRDR-IG. So that includes a death certificate document, any additional resources, and value sets describing the values in those resources. An example might smoking status, and the actual value for that field. And then a coding response is returned from the National Vital Statistics System to Vital Records jurisdiction. That also makes use of the FHIR messaging implementation guide to define the envelope, but the content for that coding response is at this time also defined in the FHIR messaging IG. So that includes things like coding of race, ethnicity, cause of death, rejection codes, and so on. So starting to get into some more of the details about the API itself, one question that's come up in the past is what will be the approach for securing this API? All connections are encrypted using the Hypertext Transfer Protocol Secure, which essentially uses the SSL or TLS protocol. This is the same type of security that you get when, say, you're using a web browser connecting to a bank. The data is protected using encryption, and the endpoints of the connection, the bank, in the case of my example, has a certificate which lets the browser validate that it's connecting to the right place. So that same protocol will be used to provide protection for all of the data being submitted to this API and retrieved from this API. Another important part of security is access control, ensuring that only people who are granted access can make use of the API. So that access control is going to be implemented using the OAuth, or Open Authorization 2.0 standard, which is an open standard for authorization and delegating access. A quick walkthrough of the way OAuth is expected to be used. The way it will begin is that a vital records jurisdiction representative will request an account. And this is actually all going to be managed through CDC's SAMS interface. So if you're familiar with SAMS or even already have a SAMS account, that would be appropriate for this use. This is a step that may have already taken place. When an account request is made, an identity proofing step will need to be done just to ensure that the jurisdiction representative is actually who they're claiming to be. Once that's completed, the representative's account is approved and credentials are issued to that representative for the jurisdiction. And from that point forward, the jurisdiction system will use those credentials for getting access to the system. And the way that happens is really a 2-step process. First, those credentials are used to retrieve a token, and then that token is sent with every request to the API to validate each request. And at some point, that token will expire, and then a new token will be requested. And There are client libraries for essentially all development environments for making use of OAuth. So the process when using one of those libraries is pretty straightforward. And we're not going to get into the sort of the hands-on technical details today. We'll do things like that in future technical sessions. But this just a high-level sketch of how it's intended to look at this point. So at this point, I have just a few more slides, and this is a little bit more technically focused from here on for any folks who are on the technical side of this work effort. There's not too much content to cover. I promise it won't take too long. So I mentioned that the first step with interacting with the API is requesting an OAuth token. So essentially, this is a request to the API system, the OAuth host portion of it, asking for a token. And as a way to just show it simply on a screen, using basically the syntax that would be used to do this using curl. Curl is just a very simple tool that allows manual interaction with an API. It's often very useful during development to get a better sense of how an API works or to debug interactions with an API. It's really shown here just for demonstration. A jurisdiction implementation that's doing this would be using curl. It'd be using code that's part of the appropriate vital record system. Using curl just lets us show in a fairly straightforward way what the actual request would look like. And in this case, it's a post request. It is going to a URL that is the token request URL for the OAuth server. And it's using the grant type of password, a client ID, a client secret, a username, and a password. And the OAuth server, if all of these things are valid, will reply with a token that can then be used for all subsequent requests. Now, once we have that token, we can start sending messages. And sending messages is a fairly, there's a few steps to getting to the point where a message can be sent. The first is actually creating the FHIR record. And that's something that we've covered in detail elsewhere. We won't talk about it in detail today, but essentially it is mapping the data that is in the jurisdiction's electronic death registration system or backend database system and putting it into the FHIR format. Once it's in that format, the next step is to create a FHIR VRDR message that acts as an envelope for the record. And then very simply, that envelope containing the record is submitted using a post request to the bundles endpoint of the API. And again, here, an example of how that could be done using curl. It's done via a post request. It's done to the API, to the /bundles endpoint, a specification of JSON as the header, because in this case, the record and message are encoded using JSON. The next header line, you can see that it has an authorization of bearer type, and the OAuth token just needs to be provided there. It's a simple string, and then the data itself. And so with that, a record is submitted to NCHS via the API. And this is the same process for initial submissions, for updates, for voids, and so forth. Any sending of a message or a record to NCHS is done using this same process. And once that submission has been sent to the API, to the server, the API will return a 204 success code on success. And that's just shown here, 204 no content. You can see we are completely uploaded and fine. Just to be clear, this 200 flavor return code is just indicating that there was a successful post of the data to the server. It's not actually indicating anything about the quality or readability of the payload. That will happen with a separate acknowledgement message that will be sent in response, which we'll get to in a moment. So we've talked about posting messages to the API. There's also the reverse flow of data from NCHS back to the jurisdiction. And in this case, receiving messages can be done by using a GET request, again, to that same bundles endpoint. The idea behind this is that this will be a regular request that's made to the server by the system to look for any new responses by the jurisdiction system. And to make this efficient, there's the option to provide a last updated parameter, which basically, if you keep track of when you last checked for updates, and each time you provide that time of when the last check occurred, right, this would be something that would be preserved by the system, just a timestamp of the last access. Basically, it's saying, please give me all of the new messages since the last time I checked. And this request is even simpler than the post request. It's, again, here demonstrated using curl. All it needs is that authorization header containing the OAuth bearer token. And then here it's just a GET request to that bundles endpoint with the last updated string with the date time information. And these GET requests return a 200 response header with the body of the response containing a FHIR bundle of type search set containing a list of FHIR messages. And these messages can be acknowledgements, they can be error messages, they can be coding responses. Essentially, each of these FHIR messages is its own envelope containing a response, which then just can be processed one by one. And I'll note that the response itself, can be fairly substantial in size, and I didn't want to try to squeeze it onto a slide. So what I'm going to do at this point is actually switch to a web browser. And I'll actually post this URL in the chat as well. This is actually the GitHub page that contains the reference implementation of the API. So let me paste this in to the chat so that you have it. So this site contains documentation for using the API that's in this README that's below the list of files. It also contains the reference implementation itself of the API developed for .NET using C#. That implementation is probably not likely of direct interest for developers at jurisdictions, but it is there for reference should it be of interest. So this documentation covers a lot of the things that I just talked about earlier. And I'm going to scroll down into the section of interacting with the API. Again, sending messages, receiving messages. Here's that last curl command for receiving a message that I shared on the slide. And then here we can actually see in the documentation page an example of what the response looks like. And as mentioned, the response is basically a FHIR resource of type bundle, of resource type bundle with the type of search set. And essentially it's a list of entries where each entry is one of these FHIR messages, right? So here is the FHIR message itself for the first thing being returned. It itself is a bundle, right? A FHIR message is encoded using the FHIR bundle resource. And within that message, there's essentially, you can think of it as an envelope. There's the address information on the envelope. Here, the destination is the jurisdiction, the source is NCHS, and then we also have right on the envelope itself a response saying, okay. And that's essentially our acknowledgement saying, message was received. We were able to do the initial parsing of the message and pull data out of it. Everything is looking good. And then we can see some additional information like the certificate number, the state auxiliary ID, the jurisdiction identifier, the year of death, all of the information that uniquely identifies a particular death record. So that's a very quick overview, both of what an API is, a little bit more detail on this particular API, and then just a little bit of a dive into what's needed from a technical perspective to get started using it. One more thing that I'll just share briefly. There is another companion GitHub repository, which is essentially a reference client implementation. So the expectation is that jurisdictions will submit FHIR records to the API, which involves a certain amount of development of code to actually accomplish that submission. We've put together a reference implementation of what the jurisdiction code could look like for submitting that as an example. So anyone who's doing development of that type of API client can take a look at this as example code for understanding what implementation could look like. And more than that, this is all released as open source. So the intent is that if this implementation is a sufficiently good match, so if it's a match for jurisdiction's infrastructure, and if it's desired to use some components that are pre-built, this reference API can also be used in that fashion as well. I will note that this is still a work in progress. We have some documentation in the README at this point. There's currently some work taking place on what's called a pull request, which adds more information to the documentation. I'm going to share this link as well. I do want to make clear that it is a work in progress. At a later date, we will walk through this in some detail, but certainly okay sharing it now, even though we're still working on it. Happy to get any initial and early feedback on it. Again, understanding that the documentation is not currently complete on the main page, and the implementation itself is still in progress and being tested.